Welcome to the 124th annual Bocce Ball World Championship here on ESPN8, The Ocho. I'm Johnson Burgermeister here today in Milan, Italy with Giovanni Manicazzo. I don't understand why all these names have to be so complicated, Giovanni. What do you expect to see today?
Well, first of all, you mispronounced my name. It's Giovanni Manicazzo, not Cazzo. Jesus Christ. And I expect the French team to lose. I expect the French team to lose since, as World War I showed us, the French are only good at surrendering and making food. As when Hitler marched in, they made him croissants.
Ah, very complicated word, croissants.
Yes, that's nice, but you know, the Italian teams are going to be serious competitors in this thing.
How many teams are there?
Well, Italy has brought 8 teams since it is the country where bocce originated, and well, it's really the only place it's played. The US has a team, but it's made up of all Italians, so they count as another Italian team, making the total 9. Then France, Germany, Greece, Russia, Great Britain, Wales, and for some reason I can't quite understand, Sudan.
Yeah, well, you know, you always need some diversity. Sudan might turn out as the real dark horse in this tournament.
That's pretty racist there, John. Now, let's go down and look at the first round, as you can see is being played currently.
Now, if you look at it, the only reason those balls move is because of the unbalanced forces are acted upon them by the force of the thrower's arm right there. This, of course, is highlighted in Newton's first law of inertia that states an object at rest will stay at rest unless acted upon by an unbalanced force. The best motion is when the thrower can keep a straight toss and a sure follow-through without breaking the wrist.
Yes, keeping the wrist unbroken is very important. When you break your wrist, that applies an unbalanced force of spin, which, when the ball lands, is very bad for the direction you want the ball to go. It will turn and move away from the aim spot. But then it can also use this to advantage, as you see this man is doing right now. He applies a backspin to it to keep the ball from going out of play.
That's a great point, but I was mentioning more of a literal form of breaking the wrist, like, you know, it's very difficult to toss a bocce ball with a broken wrist because your wrist is broken.
Yes, John, that is implied, but notice the independent unbalanced forces are very important for the overall play of the game.
What do you mean, Gio?
Well, Johnson, the players have to be able to understand the effects of the unbalanced forces have when playing the game so they can get the best outcomes. Knowing how the arm motion will accelerate the ball, how the ground will affect the direction the ball travels in, and how spin and contact with other balls will result in different actions or motions are very important.
Yes. Now that you mention it, that does sound very important. You would think that the Great Britain team would do better considering that all that is related to Newton's first law. You know, Newton was English.
Yes,
he was a knight.
Yes, he was, but that doesn't enhance a country's adoption of his teachings. Italy cherishes this game and really takes it to heart all the ways to enhance its play.
Yeah, and ever since England was shut down from conquering the world and that whole imperialism thing, they just really haven't been the same. Now, if you look at the speed and velocity of the balls when they're thrown, it is much more strategic to have more speed on the Polino and then have more velocity on the spin of the other balls, or is there any game plan at all regarding speed and velocity?
Well, if you look at it scientifically, speed is just the magnitude of the velocity, which is and velocity, of course, being the direction of the speed. So the entire game plan is based around the original velocity and speed of the Polino. That's the little white ball there, in case for our American viewers.
Actually, it's orange.
Yeah, in this video, it's orange, excuse me. Typically, it's white. John.
Yeah, so that you just have to put more on each of the other balls in relation to the location of the Polino?
Yes, and that all of the other balls will need more velocity, and thus will have more speed in order to trade the same distances as the Polino, because the Polino is so much smaller than the other balls, it has less mass, which makes it easier for you to accelerate.
Ah, exactly right. Similarly with the throwers, the magnitude of how they throw the ball has great implications. If the magnitude is constant from the Polino to the bocce, the thrower will most likely be at a disadvantage because the bocce won't travel as far, and that is why magnitude and acceleration are just as important when playing this sport, correct?
Correct. Magnitude being the greatness and measure of the velocity, of course, or speed, and acceleration being the rate at which the velocity changes.
Ah, and that's right on spot, my friend. If you watch a bocce throw in slow motion, there are multiple changes up here. You will always see the parabolic nature that is represented from the motion of the projectile.
Okay. Funny that you should bring up projectile motion, Johnson. Let's go to the physics big board here, as I like to call it, so that we can break down how you calculate the range of a thrown projectile.
You Italians really are strange.
Yeah, I know. This is what we think about. Ever since World War II, we just have so much time on our hands. I don't know what to do. Anyway, let's look at this. As you can see here, you have our bocce player right here, and he is throwing the bocce, which is this little ball right here that I'm now making bigger, and the angle that he's throwing at is marked as theta. So,
what's theta?
Theta is a Greek letter, and you really need to work on your education system in the United States. Let's say that theta is 35 degrees. Is that what you meant?
Yeah.
Oh, okay. I'm sorry, John. Let's say that theta is 35 degrees. Now, in order to figure out the distance that this ball will travel, you just need to plug all of your variables into the equation. It's sine 2 theta, right?
Yes.
Yeah. And, excuse me, let me just throw a 2 in there. All right.
I need to work on my education.
Yeah, you just shut up. Shut up. Okay. We have velocity being 15 meters per second squared. So let's come down here. Distance equals 15. Well, not squared, but it's squared because you drop down the 2. And you multiply it by the sine of 37 times 2, so 35 times 2 is 70, which is theta, over acceleration, which is 9.8 meters a second.
No, it's over gravity.
Or gravity, which is 9.8 meters per second, which is the negative acceleration. So let's see here. File, new. Don't save changes. Okay, so let's put that into our calculator. All right, so there's our equation, and my friend Giovanni, or not Giovanni, John. I'm Giovanni. See, this is confusing because in Italian, Johnson's name would be Giovanni, of course, and this was a cruel joke by the scriptwriters. Let's see what this comes down to, what our distance will be in meters for a ball thrown at the velocity of 15 meters a second at an angle of 35 degrees.
I think that's right.
We think it's 17.76.
Here, if we go,
meters.
And then sine.
And that is how
17.
you calculate velocity. Now, there's another very interesting thing about parabolic motion, right? So let's move on here. I'm going to draw you a quick diagram. A funny thing about parabolic motion. So let's say that this is the parabola. We were right?
We were right.
Good. So let's say that this is the parabola of your bocce ball here. Now, when the bocce is here, or any other place on the parabola, thank you very much, John, for making the bocce look like a pear.
Welcome.
You have two. You have a force that is operating independent of another force. In this case, you have horizontal velocity, which will always be constant, and you have a constant negative acceleration, negative vertical acceleration from gravity. That will also always be constant. And this is actually something that's really interesting and kind of hard for people to understand, that these two things are unrelated, but they are both always constant. Let's go back to the gameplay now.
What a great description, Gio. It's really a thorough and not helps me understand at all.
Well, thank you very much, John, but that's not all. There are lots of specifics on how the bocces and Polinos speed up, slow down, and change direction.
Yeah, I don't know about that, so you should elaborate more.
Of course I will. When the thrower is applying net forces to the balls accelerate and speed up depending on which force outweighs the other. However, they accelerate differently because of their masses. The Polino is such a smaller ball that has a smaller mass, therefore it accelerates much quicker and easier than the bocces because...
The bocces have larger masses. It makes so much more sense. Now, if only my high school science teacher explained to me these concepts using bocce balls, I would have done so much better in that class.
Yes, and so then magnitude
makes acceleration greater or smaller. Gio, we already covered this point. Can we just move on? Thank you.
Wait, before we move on, we have to allow our audience at home to look at these diagrams made by fantastic physics students.
And remember, you're watching ESPN 8, The Ocho.
All right, let's look at our first free body diagram describing the positive acceleration of the bocce. As you can see, I've drawn two force arrows and how they relate on the bocce, the force being on the positive side being unbalanced, greater than the force on the negative side, and then if you look at the bottom green arrow, which represents the acceleration, we can see that the ball is accelerating positively because of these forces.
That is very interesting, Gio. It's just kind of makes sense.
It makes a lot of sense. This is actually relatively basic stuff. Now I'm going to show you how it what negative acceleration looks like. As you might assume, you have the bocce again right here, and you have your positive side, which we'll use the same color, and your negative side. I think I used red. I'm not 100% sure. But now, instead...
You did it opposite last time.
Yeah, okay, shut up. Okay. Now, instead of having the unbalanced force go in the positive direction, we have it going in the negative direction, causing acceleration in the negative direction as well. See, this is relatively basic and a great understanding, and a great understanding of accelerating forces. Now let's...
All right, now listen to this great music while you think about this. All right, everybody, welcome back to ESPN 8, the Ocho. So, Jimbo, what happens when bocces collide with each other?
When the bocces collide... What the hell is that, John?
Oh, sorry, it's Epic Sax Man. I apologize.
Epic Sax Man? That was pretty epic. Is his name Sergio?
No, it doesn't tell us what his name is.
Well, Sergio is a sexy sax man.
All right.
Anyway, when the bocces collide with each other, and when the Polino, the second ball, exerts a force of equal magnitude just in the opposite direction. Like when you push against a wall with a rolly chair or jump off the ground, you exert force on the wall or the floor, and the wall or floor exerts a force right back at you.
But if the balls had an equal amount of force behind them, there would be no acceleration between the colliding forces because the forces would cancel out because they are equal, just in opposite directions.
Right you are there, Jim.
Sweet.
John. However, in bocce ball, these applications are not present because there is only one moving figure at a time.
But one could argue that two touching balls that are not moving don't cause acceleration, but there is still a growing frictional force between them, and the friction between the balls and the sand or the court also causes friction, which is a force but doesn't increase acceleration.
That is true. I personally know about two balls that are almost always touching and not accelerating, but they don't cause acceleration because there are no unbalanced forces acting on the bodies in those
Remember,
situations.
this is on, I get this is Italian national television, but it's still national television, so... Okay, but the thing that I'm most confused about is the law of conservation of energy thingy.
What?
Well, you seem very well versed on all this physics stuff, so I have been reading the Wikipedia page on physics.
What's Wikipedia?
Oh, it's this great website that knows, like, everything, and without it, I would not have passed high school.
What do you mean?
Copy and paste. Well, how about that law I asked you about?
Right. So, the law of conservation of energy states that the amount of energy in the system is constant, but can change from one form to another, such as stored potential energy to kinetic energy.
Oh, okay, but how does that work in bocce? Because the balls don't have any energy.
But they do! They have mass, so their mass allows them to have that much energy. Also, the thrower has stored energy in their muscles, so that is included in the system. Another term is work. Work is measured by the amount of energy transferred over a certain distance or applied over a certain distance on a certain object. In bocce, the athletes do work during the throwing motion, and then there is gravitational potential energy while the ball is in the air.
All right, Giovanni, you're starting to sound like an Italian physics version of Bob Costas. All this talk is really taking away from the game. Let's go down to the court. Remember, you're watching ESPN 8, the Ocho.
And
Dun, 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 dun.